Hi everyone, we're starting our new unit on expansion and factorization. Some of this is going to be quite simple for many of you because a good part of it is going to be a review, but we're going to be reviewing this very quickly. So we'll be finishing up a chapter or two in no time. Alright, so the first thing we're going to be looking at is expansion, and we're going to be looking at sections A, B, C, as well as D. So if we're looking at Chapter 3 in the MYP 9 textbook that's on your Google Drive, we're going to start looking at algebraic expansion and simplification. And the first thing we'll be looking at right now is we'll be looking at just collecting like terms. I'm sure many of you have already done this in 7th, 8th grade, but we're just going to quickly review it. So when we are looking at like terms, we are looking for variables that are the same. So for example, AB and 2AB are going to be considered like terms, and that's simply because AB and AB exist in both of those expressions. Now, the fact that there is no coefficient in front of the first term here, AB, there's no coefficient or no number in front of it, simply means that there's actually a 1. So by default we know that it's a 1. And the other next one next to it is 2AB. Right, x and xy are not considered to be like terms. They are unlike terms. So what we normally do is we simplify algebraic expressions by adding and subtracting like terms. So, for example, again, we have a table here. 4x and 3 are not considered like terms. The second term, 3, has no variable on it. 4x and 3y are not considered like terms because the second term has a variable, but it's not the same as the first one. So x and y are two different variables. And then we have, in the third row, we've got 4x and 3x squared. They're not like terms, again, although they both have an x on them. One of them, though, has x on it, whereas the other one has x squared. So the degree is different here. So x and x squared are two different terms. Okay? And then the last example is one where we do have like terms, where we've got 4x and 3x, where x and x are matching up so that we know that they are like terms. They have the degrees that match, and as well as the variables that are the same. So if we want to quickly do an example here, we can do an example of 3x plus 4x. Well, the degrees are the same on the x's. They have the same variable, and therefore I just add up together my coefficients, where 3 plus 4 is 7x. Please be aware that 7x, it is 7x and not 7x squared. Okay, so the second term I'm going to, for the second example, we're going to look for like terms again. So I've got an x squared here and an x squared there. I've color-coded in red. Then I've got an x and an x that I've color-coded in blue. And then I have my remaining coefficients, or my remaining values to be -4 and +9 in green. So I add up 2 and -1x squared. So 2x squared minus 1x squared gives me 1x squared. -3 plus -3x plus x gives me -2x. And then -4 plus 9 will give me +5. So there's my solution there. Alright, the next examples we'll just do very quickly. So you are asked to simplify where possible by collecting like terms. So if I have 10x cubed minus 14x squared plus 3x minus 4x cubed plus 4x minus 6, I again am collecting like terms. So x cubed and x cubed will collect together. There are no other x squareds, but we do have x terms that can be collected together. Now, if you wish, you can actually bring them closer together so that you may group them, so that you can say 10x cubed minus 4x cubed minus 14x squared plus 3x plus 4x, and then we have minus 6. So that now we can simplify further. So 10x cubed minus 4x cubed will give us 6x cubed, and -14x squared doesn't have anything else that it can work with, and then plus 3x plus 4x is plus 7x, and then minus 6. keep in mind that when we are working on these types of problems where we are collecting like terms and we've got the same variables but different degrees, generally speaking what we do is we go from putting our answers down from the highest degree to the lowest. So we go from x cubed to x squared to x to no variable or no degree. And generally speaking, that's how we do this. We go from the highest degree to the lowest, just to be organized. All right, the next example is 10a minus 3a plus 2ab plus 5ab. Again, very simple. Our like terms here are 10a minus 3a, which gives us 7a, and then 2ab plus 5ab gives us plus 7ab. Done. All right, so just be very careful. I always tend to put this as an explanation in my in whatever I do when we're talking about algebra and multiplying and adding and subtracting and so forth. So do not get careless and confuse multiplication and addition. I know it sounds absurd, but it's a very common mistake. Whereby, for example, we know that x times x is going to give me x squared. That is right. That is correct when I'm multiplying. But when I am doing x plus x, my answer turns out to be 2x. The answer is not going to be 2x squared. It's not going to be 2x squared, nor is it going to be x squared, where I add my exponents together. It's just what is in front of the variable. So our coefficient in front of the x is a 1 and a 1 in this case. So because the variables are the same, they have the same degree, it's just 1x plus 1x, which gives me 2x. Okay? So we do not have anything along the lines of x cubed plus x squared that becomes x to the fifth. That is definitely a no. That would just give us nothing, in that I cannot add x cubed and x squared together. The terms are different. Okay? And they are not x to the fifth, and nor are they 5x. So if you have something like 2x plus x, our answer is 3x, and it's not going to be 2x squared. So please be careful on this sort of question. All right, if we go into section 3b on algebraic products, so we're moving away from adding and subtracting like terms, but we are looking at multiplication. So if I were doing negative 4x multiplied by, so I've got negative 4x multiplied by 3x cubed, so negative 4x multiplied by 3x cubed. What I'm going to do is I'm going to multiply the coefficients together. So multiplying the coefficients together, or the product of the numbers, it'll be 4 times 3, which will give me 12. I see that the first term has a negative on it, the second term does not have a negative on it, so that means that a negative times a positive will give me a negative. And then I find the product of the variables. And the product of the variables is x times x cubed, which means that I have x to the power of 1 here times x cubed, and that will give me x to the fourth. So that my final answer will be negative 12x to the fourth. Let's do a very quick, let's do a couple of examples here, so that I will say 2 times negative 6 will definitely give me negative 12. Now, a squared times a is like saying a to the power of 1, so it's a squared times a to the 1 gives us a cubed. And then b times b squared is going to be, again, b cubed. And then, since there's only one value of c, my answer goes to c. So it's negative 12a cubed, b cubed, c. Next example, we've got multiplication here in the first half. We've got a minus sign in the middle, and we've got a multiplication in the second half. So that I will do 2 times 3 is 6. X squared times y gives me x squared y. And then x squared, and then 5 times 2. So it's a minus 5 times 2. So it gives me negative 10. And then x squared times y gives me x squared y. Now, because we have the same terms, we're collecting like terms, it's x squared y and x squared y, then we're going to end up having negative 4x squared y. Alright, next, distributive property. Well, the distributive property you would have learned absolutely in either grade 7 or 8, but let's just do a very quick review of it. So when we multiply a term by a parentheses, we are expanding here. So the distributive property is a form of expansion, and that involves removing brackets or parentheses. So what we do is whatever's outside of the parentheses will get multiplied by whatever is inside the parentheses. So that A times B will give me AB, and A times C will give me plus AC. And that is the distributive property. So negative 3 times A gives me negative 3A, and negative 3 times negative 5 gives us positive 15. Please be careful to remember that the negative is being multiplied by that negative 5, so that it goes to a negative times the negative is a positive. If I now multiply 2x times x, that'll give me 2x squared, because x and x, when you add up the exponents, they go to x squared. And again, this is because it's multiplication. And then at 2x times a, or negative a, gives me negative 2ax, or negative 2xa, but we usually put our letters in alphabetical order as well when we work these out. So let me just do an aside here. Remember that if I have 2x plus x, that would give me 3x. I am adding in this situation. I'm adding like terms. In a situation where I have a product or I'm multiplying, so I've got 2x times x, well, what I do is I add together the exponents of the like terms so that it goes to 2x squared. Okay, let's do one more down here. So 2 times a is 2a, a times negative b is negative ab, and a times positive c gives me positive plus ac. Okay, let's expand on the next one. So let's look at some more complicated examples. We've got 2x times 3x minus 7 minus 4x times 2 minus 3x plus x times x minus 2. So 2x times 3x gives us 6x squared. 2x times negative 7 gives me negative 14x. Don't forget that negative. Now negative 4x times 2 gives me negative 8x. And then again, negative 4x times negative 3x will give me a negative times a negative gives me a positive 12x squared. And then it will be plus x squared plus 2x. So my last step here is to collect all the like terms. So by collecting the like terms, I end up getting 6x squared plus 12x squared is 18x squared. Negative 14 minus 8x is going to give me negative 22x. And now I've got left over, though, because I just noticed, a plus x squared plus 2x. So that means I'm just going to go to 18 plus 1 is 19x squared, and negative 22 plus 2 gives me negative 20x. My next one is, again, a distributive property, but it's a distributive property where there's a 1 in the front of that negative. So it's negative 1 times 3x gives me negative 3x, and negative 1 times negative 7 gives us positive 7. A couple of other questions that we have are negative 3 times 2a is negative 6a plus 12, and then minus 3a plus 2. And again, we end up getting our common terms that get collected together. So negative 6a minus 3a is negative 9a, and plus 12 plus 2 gives me plus 14. Another example would be then 2x squared minus 14x, 2x squared minus 14x. Then it's minus 2x squared, and then plus 3x. So that 2x squared minus 2x squared cancels itself out, and negative 14 plus 3 would give me negative 11x. Okay, next is section D. This is FOIL. You all learned how to perform FOIL or how to do FOIL last year. So the product is basically saying that every term in the first parentheses is going to get multiplied by every term in the second. So we're doing the first, the outer, the inner, and the last. That's what FOIL stands for. So that we have AC plus AD plus BC plus BD. It's the first, so it's first, outer, inner, and last. Okay, that's what that stands for, FOIL. Alright, so if I need to expand here, I will do 3x times 1 is 3x. 3x times 2x is 6x squared. Negative 2 times 1 is negative 2, and negative 2 times 2x is negative 4x. I can then simplify that, so I collect all my like terms, so that we have 6x squared minus 4x plus 3x minus 2. I just collected my terms here, and I placed them in order of degree from largest to smallest, so that I have 6x squared minus x minus 2. If I do the same thing now again on the second and third example, I have 10x plus 2x minus 15x, and then it's minus 3x squared. And again, in order of degree from largest to smallest, it's negative 3x squared minus, let's see what we've got. We've got 10x plus 2x, which is 12x. 12x minus 15x gives us negative 3x. So there's my answer there. And let's take a look at the last example here, which is negative bracket. Now, because I'm going to perform the expansion first with FOIL, I will leave the negative out. So I will say 8x minus 2x squared plus 12 minus 3x. I'm going to simplify what's inside the parentheses first. So it's negative 2x squared, and then it's 8x minus, it'll be 8x minus 3x, which is plus 5x, and then plus 12. So now I take the negative of everything, and therefore within the parentheses I will change all the signs because I have a negative on the outside. That's like saying negative 1. So it'll go to positive 2x squared minus 5x minus 12. Alright, that pretty much covers it. What you are going to be doing in class the next period is going to be exercises 3A, B, 3C, and D. You'll be working on all of these questions. I'll see you next time.